Hey there, this is another video from my Intro Calc students, and this is, I'm calling it Example 3 of Lesson 1.4, and I think you should probably pause the video and try this in yourself. It says, use both formulas 1 and 2 to find the slope of the tangent to f of x equals 2x squared plus 4x minus 1 when x equals 2. So if you pause the video and give it a try, I'll run through the solution here in just a minute. So pause it now. Alright, how'd it go? Did you try it? Here we go. Let's do Formula 1 first. So Formula 1. So Formula 1 is, of course, the slope is f of x minus f of... Oh, wait a minute. Kind of forgot something. I don't know if you can hear that or not, but my dog's going crazy upstairs. It's the limit as x approaches a of f of x minus f of a all over x minus a. There, that's the formula. So, what do we need to know? We need to know f of x. We've got that. We need to know a. We've got that. But we also need to know f of a. So, you have a choice. You can either do f of a in formula, or you can actually figure it out separately. I'll do it in formula so that I remind you again to watch for your negatives. So, the slope is the limit as x approaches a, which is 2, of f of x, which is 2x squared plus 4x minus 1, minus, and f of a is 2 times 2 squared, so I'll just plug that in, 2 times 2 squared, plus 4 times 2 minus 1. And all of that's being minus, so make sure you put that in the bracket, all over x minus 2. So I'd love to be able to just plug the 2 in and get on with my life, but I can't. So I'm hoping whatever comes out of this top here will cancel x minus 2 somehow. So let's see if that's what happens. So that's the limit as x approaches 2 of 2x squared plus 4x minus 1. And this is 2 squared is 4. 4 times 2 is 8. So that's minus. So that's 8 plus 8 is 16 minus 1 is minus. I don't know why I need a bracket if I already figured it out. That's minus 15. Okay? And all of that is all over x minus 2. So, next, that's the limit as x approaches 2 of 2x squared plus 4x minus 16 all over x minus 2. Okay, what do you think is the next trick we're going to pull out of the old math toolbox? If you thought it's factoring, you thought right. So that's going to be the limit as x approaches 2, and notice the first thing you always look for when you're factoring is there a common factor? And there is. All three of these terms have a 2 in them. So that's x squared plus 2x minus 8. And, oh, I think we saw this one just the other day, that particular trinomial. So that's the limit as x approaches 2 of 2 times x plus 4x minus 2 all over x minus 2. Those go bye-bye. This is now the limit as x approaches 2 of 2 times x plus 4. No more denominator. I can just plug in my 2 now. So that's 2 times 2 plus 4. 2 plus 4 is 6. 6 times 2 is 12. The limit is 12. I had somebody just yesterday ask me, what happens if this doesn't factor? Well, you do know how to long divide now, but I don't think any of the examples are going to do that to you anytime soon. I think the idea here is that most of these will work out fairly nicely, but in the, in a more technical situation, like you were actually an engineer doing this to find an actual slope to a curve somewhere or something, don't expect the world to give you nice purty numbers. Anywho, we were supposed to do this twice, right? So let's do it again. Let's use Formula 2. Formula 2. And if you, again, didn't try this yourself, pause the video right now and give it a try. But Formula 2, of course, is the limit, or I should say the slope is, the limit as h approaches 0 of f of a plus h minus f of a all over h. And I've been asked already, do I have to memorize this formula? No, you don't have to memorize formulas. We'll give you a formula sheet if you want. So, let's see, what do we know? We know, again, a is, what was a again? A was 2, and f of a, we kind of already figured that out in the last part of the video there. That was 15 in the last part of the example, I should say. And we, again, know that f of x is the parabola we're looking at, which is 2x squared, what is it, plus 4x minus 1. So that's all the information we need to run through that formula. So it's the limit as h approaches 0 of f of, and a plus h. If a is 2, then, a plus h is is 2 plus h. And you can write that as 2 plus h or h plus 2. It doesn't really matter. So I'll stick with 2 plus h. So it's the limit as h approaches 0 of f of this, of 2 plus h. So 2 plus h gets plugged into this formula. So that's 2 times 2 plus h, all squared, plus 4 times 2 plus h, right? X squared, x, and then minus 1, minus f of a, which I already know is just 15, all over h. All right, so I'm going to have to expand this, aren't I? So that's going to equal the limit as h approaches 0 of 2 times, expanding that squared, 4 plus 4h plus h squared. And this, of course, is 8 plus 4h, minus 1 minus 15 is minus 16. Getting there. Remember, the goal is to hopefully make all these constants go away so I can divide out the h. So let's keep going. So that's the limit as h approaches 0 of, that's 2 through that bracket, which is 8, 8h, 2h squared, plus 8 plus 4h minus 16. And yep, oh, I can see it coming. Isn't that lovely? 8 plus 8 minus 16 means no more constants. So that's the limit as x as h approaches 0 of 8h's plus 4h's, which is 12h's, plus 2h squared, all over h. And now factoring usually says look for the greatest common factor, so you could factor out a 2h, but at the end of the day, all I really care about is killing that denominator. So I am going to make that the limit as h approaches 0 of h times 12 plus, oh, look at that, now I forgot the 2. 12 plus 2h, all over h, right? So I factored an h out of those two terms. Now it gets canceled, and that is equal to the limit, no more denominator. Well, I mean, there's a denominator, but it's 1 of 12 plus 2h. Now I can plug a 0 in here, so that's going to be 12 plus 2 times 0, which is 12, which is a good thing because that's what we got with the other formula. And if you did it with the other formula, you have to get the same answer you get with this formula, and that does it. So there's another good example. I'll post another video of another example that's a little harder in just a few.